Welcome back to our channel. Today, we're diving into one of the most famous scientific theories of all time, Einstein's theory of relativity. Whether you're a science enthusiast or just curious about the universe, stay tuned as we break down this complex theory into simple, easy-to-understand concepts. So what exactly is relativity? In simple terms, it's a theory by Albert Einstein that describes the laws of physics in the context of moving bodies. Einstein's theory is divided into two parts: special relativity and general relativity. Special relativity, published in 1905, focuses on objects moving at constant speeds, particularly at the speed of light. It introduced the famous equation E equals mc squared. General relativity, published in 1915, expands on this by including gravity and acceleration. It describes how massive objects cause a distortion in space-time, which we perceive as gravity. Special relativity is based on two main principles. First, the laws of physics are the same for all non-accelerating observers. Second, the speed of light in a vacuum is constant and independent of the motion of the light source or observer. One of the most fascinating implications of special relativity is time dilation. This means that time moves slower for objects in motion compared to those at rest. For example, astronauts traveling at high speeds would age slower than people on Earth. Another concept is length contraction, where objects in motion are measured to be shorter in the direction of motion relative to an observer at rest. These ideas might seem counterintuitive, but they've been confirmed by numerous experiments, like those involving high-speed particles and accelerators. General relativity takes things further by describing gravity not as a force, but as a curvature of space-time caused by mass. Imagine space-time as a fabric. When a massive object like the Sun sits on this fabric, it creates a dent. Planets move along the curves in this fabric, which we perceive as gravitational attraction. The equivalence principle is central to general relativity. It states that the effects of gravity are indistinguishable from the effects of acceleration. General relativity predicts phenomena like the bending of light around massive objects, known as gravitational lensing, and the stretching of time near strong gravitational fields, called gravitational time dilation. These predictions have been confirmed by observations, such as the bending of starlight during a solar eclipse. Einstein's theories aren't just theoretical, they have practical applications too. For instance, GPS technology relies on both special and general relativity to provide accurate location data. Relativity has also transformed our understanding of the universe, influencing the Big Bang theory and the study of cosmology. Researchers continue to explore the implications of relativity, such as the search for gravitational waves and studying the behavior of matter in extreme conditions. To recap, special relativity teaches us about the relationship between speed, time, and energy, while general relativity redefines gravity as a curvature of space-time. Einstein often used thought experiments to explain these concepts. For example, imagine a train moving at the speed of light, or an elevator accelerating in space to understand these principles better. Using visual aids like animations of space-time curvature or light clocks can help make these abstract ideas more tangible. Einstein's theory of relativity has changed our perception of reality, demonstrating the incredible nature of our universe. If you enjoyed this simplified explanation, please like, share, and subscribe for more intriguing science content. Leave a comment below with any questions or topics you'd like us to cover next. Thanks for watching, and we'll see you in the next video.